For years, the promise of a decentralized web has been simple: a digital landscape where you own your data, free from central corporate servers. To build that landscape, developers have overwhelmingly turned to blockchain technology. But looking at this architectural diagram of a standard blockchain, you can see a heavy intermediary layer between the applications and the network. This decentralized ledger is a global database where every participating node is forced to maintain a complete copy of every single action. This next diagram breaks down the operational cost. Focus on steps 3 and 4. A single transaction block must be broadcast to and approved by every part of the network. Zooming out to the full 6-step loop, the inefficiency becomes clear. Repeating this cycle for millions of simultaneous transactions requires massive computing power and slows the system to a crawl as more users join. Think about how physical networks work. A city doesn't slow down because a new neighborhood is built. It expands its capacity. What if a digital network could actually become faster as it grows by abandoning the global ledger entirely? Achieving true, scalable decentralization requires leaving behind data-centric bottlenecks and adopting a completely different architectural approach. Holochain flips the traditional network model inside out. Instead of building a system around a central server or a global ledger, it uses an agent-centric model, where the foundation of the network is the individual user. In this system, the agent is simply you, operating independently on your own phone or laptop. This schematic shows how local authority works. The far left local agent state reveals the source chain, a private ledger on your device. Following the downward flow, your digital actions are signed directly into source chain transactions. You are the absolute sole authority over your local state. By isolating data locally, you never have to ask a global network for permission to act. You just act. If everyone has their own private ledger, the immediate question is how the network prevents independent agents from cheating or altering their own records to benefit themselves. The answer lies in the application code itself. Every user participating in a specific Holochain application runs the exact same code, known as its DNA, which establishes the immutable rules for how data can be created and shared. If an agent attempts to rewrite their local DNA code to cheat the system, their data will fail to match the established rules. They sever their own connection, automatically isolating themselves from the rest of the network. The center panel reveals the shared DHT cache for public interactions. Arrows from publish to DHT show data isn't broadcast globally. Instead, sharding pushes data to small, random peer neighborhoods. These witnesses run system and app validation, storing valid data and blocking bad actors. Combining absolute local authority with this random, localized peer witnessing creates a secure, trustless environment, all without the sluggish drag of a global consensus bottleneck. The functional result of this architecture is a system that delivers the cryptographic security of a blockchain, but entirely sidesteps the scaling bottlenecks. Because validation is localized and distributed only among small neighborhoods of peers, the network's processing power actually increases as more users join. This capacity enables heavy, data-intensive applications that traditional blockchains simply cannot support. Developers can build massive social media platforms, complex global supply chains, and vast grids of interconnected IoT sensors. For the person actually using these applications, the architecture guarantees absolute digital sovereignty. Your data remains on your device, controlled entirely by your cryptographic keys. It proves that massive global coordination is possible without a central authority, keeping the individual user entirely at the center of their own digital life.